Welcome to a roof math intro. We're going to talk about the SGF slope gain factor for 90-degree rafters to the plate and rafters that run at 45 degrees to our top plates. So what happens is that we want to make things simple for us. Whenever we have a roof, it's going to have a slope that'll usually be given to us. And a slope is nothing but a ratio and proportion. There's a unit rise and a unit run. And we want to use that ratio and proportion to change any triangle to a base 1 triangle. So instead of having, let's say, 180 over 250, 7 over 12, a 1 over 2.4, whatever it may be, we want to turn that unit run into a 1, which means we divide it by itself. And then we have to do the same to the unit rise. And with that, check out this triangle, right angle triangle. We can do Pythagorean a squared plus b squared equals c squared, which is actually our slope gain factor. And then all we need to find on any roof is the run of the rafter and multiply it by that slope gain factor. And that gives us the line length of the rafter. We'll go through a couple of practice examples here as well. And for this one, with the base 1, it's for any rafter that's at 90 degrees to the ridge or to the wall plate. So not just a common rafter, but it can be a hip jack. It can be any of the valley cripples, anything that's 90 degrees. So we have our a squared, unit rise squared, plus our 1 squared from the base. And then remember to take the square root, and that gives us the SGF for 90 degrees. So let's do an example. We have a roof slope of 180 over 250. I always like to draw it out in a triangle. 180 is the unit rise, 250 is the unit run. Then I draw the exact same triangle again, but this time the base is 1 because that's what we aim for. So 250 divided by 250, so by itself, equals 1. And we have to do the same for the unit rise. So make sure you have a calculator, just follow along, and then it'll help make more sense for you. So 180 over 250 is 0.72. Now to get our actual SGF slope gain factor, a squared plus b squared equals c squared. So the number that we're going to be working with is the 1.232. Here's another example. Roof slope is a 712. And you see, these are just proportions to each other. They can be any number, and you can turn them all into a base 1. So we draw our triangle. Unit rise is 7, unit run is 12. And then we draw the same thing again with our base 1. So 12 divided by 12 is 1. 7 divided by 12 is 0.583. Now one extra step. A squared plus b squared equals our SGF, which is 1.158. So all this means is that for every unit run of 1, the rafter will rise 0.583. And what that means is for a run of 1 on the horizontal or in plan view, the line length of the actual rafter on the slope is 1.158 times as long as it is in plan view or the horizontal. That's all that it means. So let's do an extra exercise here. So we want to find the common rafter line length. We have a gable roof here. Let's have a look. It's 14,000 long. The width is 8,500. We have a ridge in the middle. Slope is a 712. And the projection is 400 that I didn't draw in here. So that's for the overhang of our roof. So to find the rafter run, we take the span or the width of the building and divide it in 2 because the rafters only go halfway from the plate to the ridge. Then we figure out our SGF. Always do that first. So draw our first triangle. Our slope is a 7 to 12. And then draw the same thing again, turning it into a base 1. So 12 divided by 12 is 1. 7 divided by 12 is 0.583. A squared plus b squared equals our SGF, which is 1.158. And that is the number that we want to work with. I always like to draw myself these triangles when I figure out rafters, and it's very important that you mark what you're figuring out. Once you get into hip roofs or more complicated, equal pitched intersecting roofs, you're going to have a lot of triangles, and you want to make sure you keep track properly so that you don't just have a bunch of triangles with numbers and don't actually know what they are. So this basically represents our rafter. We have a rafter run of 4250, and we have a projection of 400. All we need to do is take our rafter run, 4250, times our SGF of 1.158. And that gets us the line length from the ridge to our bird's mouth, basically, to the outside of the building, the theory length, before you make any adjustments. And we do the same for the tail. 400 times our SGF of 1.158 gets us 463. Now, for layout purposes and to find the total common rafter line length, we want to add those together as well. So that will be the total length of our rafter. Now, when we talk about hip roofs, that hip rafter runs at 45 degrees to our regular outside plates. And we want to do the same kind of thing with the slope gain factor, but we can't use the base one here. So just to show, we have our common rafter run, and our hip rafter sits on that same plate but at the corner. And the important thing is here that they have the same rise, the same total rise and the same unit rise, because they meet at the ridge at the exact same spot. So the main difference and only difference is really that the hip rafter run for each unit is larger than the common rafter run. And I'll show you here how that works. So this is a plan view of a hip roof. We have our common rafters, we have our last common rafter, and we have our end or pin rafter. And let's just imagine we turn our common rafter one run into a 1, just to make this simple. If this common rafter run here is 1, then that's the same here, right? We're just moving it out a little bit. And because it's a right angle triangle, this is also the same. And we know it's the same because that pin rafter also sits there. So we have a perfect square where each side is 1. So again, this is in plan view. So let's look at the hip rafter run. What does that look like? Well, we have a right angle triangle. We have 1 and 1, and this is the hypotenuse of that triangle. So to figure out what the hip rafter run is when we're dealing with a base 1, we just go a squared plus b squared equals c squared. So 1 squared plus 1 squared, take the square root and punch it into your calculator and see what comes out. Should be 1.414. So all that means is for every unit run of 1, or any unit run that a common rafter travels, the hip rafter has to travel 1.414 times as far, because it comes in at a 45-degree diagonal to eventually meet at the same height at the ridge. So we can't just use a base 1 because it's not a base 1, right? The base is actually 1.414, and that is all we do. We make our same triangles with a slope gain factor and make sure to call it slope gain factor SGF 45 so you don't get confused. But instead of doing a base 1, we're going to do the base at 1.414. Let's do an example. So we have a building 9,600 long. We have a 600 mil projection all the way around. It's a hip roof, and it's 7,600 wide. Now we have a roof slope of a 512. So what's the very first thing we can do? Well, we want to figure out our common rafter, so the SGF 90. We have our triangle with our slope. We have a 512, and we want to turn it into our base 1. So 12 divided by 12 is 1. 5 divided by 12 is 0.417. Now to find our actual slope gain factor, a squared plus b squared equals slope gain factor 90, 1.083. Now for our common rafter, 7,600 is the total width of the building, but it only goes halfway. So divide by 2 gives us a run of 3,800. Now we take our common rafter run, 3,800, multiply by our slope gain factor of 1.083. And it gives us a common rafter line length of 4115.4. So that's to the outside of the building. And if you want to add the tail as well, we take our projection, 600 times our slope gain factor, 1.083, which gets us 649.8. And then we add the two together to get 4765.2. Once you kind of get the gist of the base one, it's actually quite straightforward. All we ever need is our slope gain factor and find out the run of a rafter. Again, I would always draw these triangles because they're helpful, and as carpenters, we're very visual people, and it just helps keep things straight. So 3,800 for the run, 600 for the tail projection, multiply, and we come up with our numbers. So that deals with the common rafter. And for the hip jacks, they also use the SGF 90, right? Because they run at 90 degrees to the plate, not at the 45. So we just have to find the run of that hip jack and again multiply it by the slope gain factor to find the actual sloped length. So for the hip rafter, SGF 45, right? Mark that out. We have the same slope of the roof. It's the same project, right? So still a 512. Major difference, it's not a base 1, but a base of 1.414. But the unit rise is the same because it meets at the same spot on the roof. A squared plus B squared equals our SGF 45, which is 1.474. The beauty is that we can take the common rafter run and that same common rafter projection for our math of the hip rafter, or if you're getting into equal pitched intersecting roofs for the supported and supporting valley, because they're the exact same thing. They run at 45 degrees. And the way that we make sure that it works is because we changed our base 1 and our slope gain factor is larger for the SGF 45 than it is for the common rafter. So that's all we do. Common rafter run times SGF 45, and it gives us our length. We do the same for the tail because it also runs at 45 degrees. So 600 times our SGF 45 of 1.474 gives us a number, and then we add them both together and add our numbers to our triangles. And then I usually like to just write it up here again, as well as the total, just to keep track. And really, that's it. It's that simple. You only ever need to find the run of a rafter. Be very clear of what your SGF 90 is and SGF 45. Keep those separate. Always mark out which rafters you're working on. And then you're just finding the run and multiplying by the SGF, either 90 or 45. And a really common mistake here is to either use the unit rise or just do A squared plus B squared and not actually take the square root of it. That's really important. And then you are good to go.